But my name is Hock-Chye. I'm the Auditor General for the Asian Development Bank. I joined the Asian Development Bank since April of 2013, so I've been here for about 7.5 years. But before I begin, allow me to share my screen and my audio so you can see a bit more about what we're trying to do here. Okay, this is technology. Let me see how it works, okay? Okay, I'm going to share my screen and let me know if you see my screen.
Yeah, we see it clear.
Okay, you see it. Okay, let me see how I'm going to play the thing. Okay. Okay, you see the screen that says technology, success and failure on technology internal audit?
Yeah,
okay. Okay, good. Thank you. A warm welcome, my fellow internal auditors from IIA Indonesia to this webinar. And I just learned from Harry that many of you are from his hometown. So Harry is a fellow internal auditor in our internal audit department, also from Indonesia. And so he just told me that many of you are actually from his hometown. So welcome. Before I started, I just wanted to thank you for allowing us to share with you our success and failure from experimenting with technology in audit. We have, I think, about 40, 50 or 60 participants in the webinar. The webinar will be a mixture of both live as well as video presentations that will be delivered by the ADB internal audit team from 5 separate locations. We will be unpacking the webinar in 5 parts. The first, Pierre, my colleague, will present on unsupervised machine learning with sentiment analysis. Second, we will show a 3-minute video on drones where Harry will stand by for questions later. Third, Andrew, my other colleague, will present on rule-based and supervised machine learning. Maybe at this stage, I will explain what is unsupervised and supervised machine learning. In the case of unsupervised machine learning, we will teach the machine what to do, and the machine will go and do whatever it does. In the case of a supervised machine learning, we also teach the machine what to do, and the machine will also do what it does, but we validate the results. So the difference between supervised and unsupervised machine learning is the validation process. So maybe later on in the Q&A, you may want to ask us, how do we decide on whether it's supervised or unsupervised? That could be a question maybe you may want to ask us. Fourth, my other colleague, Marisol, will present on contract analysis software. That software is called Argus. It's an application. It's an experimental application that we partner with our external auditors, Deloitte, who actually shared the application with us so that we can actually work out something relating to our contracts that will be beneficial for them, external auditors, as for us, internal auditors. Marisol will discuss a bit more about what the application Argus is all about during the presentation. The fifth application, fifth and last one, will be delivered by Chris Ian. Christ here will present robotic process automation, or what we call bots. His presentation will be followed closely or almost immediately by a video presentation on the bot. Originally, we wanted to show how the bot actually works, but it got a bit complicated. So we decided to record it in the video, because in order for us to show the application, we have the bots, we have to open at least 3 applications. We have to open Python, Power BI, Excel, and a number of other databases. And it gets a bit complicated when you try to present it in a remote setting. So we thought we'll record the whole how the bot actually works, and the person who's actually speaking is actually Christ Ian. We actually recorded it and we did a voice over it. When they come to the part about the video, maybe you want to increase your volume a bit. Christ Ian is a very soft-spoken person, but when it comes to data analytics, he's a dynamo. Okay. Each application has a success and failure when we're trying to implement it. Our approach is basically to go ahead, to learn from to go ahead and try the application and learn from its success and failure, and reflect on them, and then move forward to the next step. So basically, that's our approach, is just to dive in and to plunge ourselves in and test the application to see how it works on the bite size, which means that what we call a baby step approach. And we believe also, being in the internal audit profession, we believe that by sharing what we did, we could also learn from you your insights on applying technology in audit in the spirit of progress through sharing. What I mentioned to Made earlier is that please allow us to complete the entire presentation. It'll be about like 30 minutes before you proceed to the Q&A session. However, please feel free to write your questions in the chat box, and we will get to them during the Q&A session. The Q&A session will be moderated by IIA Indonesia. And we also, as a special request to IIA Indonesia to record the presentation, so we can actually use it for future sharing and future learning for, in case if you may need it, and also others who could, who may wish to see how other internal audit shops are actually applying digital technology in audit. On that note, let me call on Pierre to dive into his presentation. Over to you, Pierre.
All right. Good afternoon from Manila, everyone. I hope you're hearing me clear. Yep, I assume that's a yes. I am Pierre Gadpay from the IT audit team of the Office of the Auditor General, and I'm here to share with you one of our first journeys in utilizing machine learning techniques in our work. But please allow me to turn off my camera for bandwidth reasons. Okay, so the traditional model. So every year, we perform a country priority assessment to allow us to prioritize and zero in on the country or country portfolio and supporting field office operations that we intend to review for the coming year. As you know, ADB is headquartered in Manila, but we have field offices all over Asia, and we actually have one in Jakarta. Traditionally, this prioritization process was supported by an Excel template. We wanted to keep things simple and explainable, so we utilized 9 indicators, which was a combination of internal and external indicators. So the approach was basically a weighted average approach, where for each indicator, the auditor gives a rating score, which allows us to come up with the weighted priorities. Now, being Excel based, our data sources were primarily static, quote unquote, or based on point in time downloads from systems and databases that we have access to. As such, we perform this once a year or revalidate the prioritization and revalidate the prioritization mid-year. As the approach was judgment-based, we also validated this for inputs by our stakeholders. And at times, the prioritization is recalibrated. For example, a key event or news may have happened in a member country that would result in us bumping up or bumping down a rating for a country. So that is where the new model comes in, the green area in the chart. With the new validation model, we actually wanted to build a tool that would automate most, if not all, of the steps we were taking while leveraging on the benefits of machine learning, such as one, ability to process more data as inputs, two, considering more dynamic and real-time data, and finally, embedding updated information on the news climate or relevant events into our model. So we decided to take what our Auditor General, Hock-Chye, likes to call baby steps into the world of AI and conceptualize this model, and initially built it together with an intern leveraging on our internship program in ADB. We wanted to be able to process more indicators, 12 in this case, build it such a way that it would eventually allow for more integration with databases, systems, and subscriptions we have at the ADB, utilize more outside data, and allow us to run the tool as frequently as reasonably needed. I will be sharing more on two applications of actually both supervised and unsupervised machine learning in the tool. Next slide, please. Okay, sentiment analysis using news titles. So the first application of supervised learning was embedding news article sentiments into the model via sentiment analysis. In the past, we relied on research and hopefully reading key news articles that would significantly change our judgment for a specific country. If we see, if we see the news article. So we thought, since we have subscription to news feeds, maybe we could somehow filter the relevant news articles for our member countries and put a score into it and embed it in the model. So this is where sentiment analysis comes in. We let the computer read thousands and thousands of headlines, and based on training data we have available from the internet, we trained it like a baby to put a score on how positive or negative the news article is. Thus, it was a supervised model as we had to train the tool to reasonably classify the headlines. So in this case, in the slide, Philippines hit by earthquake is judged as negative, while India announcing a strategic deal would be most likely a positive news. We had a subscription to S&P Standard and Poor's, and we used that as a proof of concept where using sentiment analysis using the LSTM or long short term memory, we rated the news headlines. We now have changed that actually to Google's BERT, BERT, which has more context to reading news headlines. At this stage, we still have some limitations to the model as we are using headlines only due to some technical limitations, and we are currently processing English news headlines only. Next slide, please. Now, The next slide is about the second application of machine learning, this time unsupervised learning, where we used clustering through k-means clustering. To briefly explain k-means clustering in layperson's term, imagine a plane of an axis of x, y, and z, or a plane of three indicators, let's say portfolio amount, size of office, and maybe the co-financing ratio, for example, for the country. In a person's mind, we could probably see the relationship between the 3 points because it's only 3 points. And if there are many data points, we could probably see the clear groupings or clusters. Like, for example, in this chart, one would see generally five clusters, right, based on the colors. Now, imagine if you have 10 indicators, or actually 12 in our case, or maybe 100 in the future. At that point, it becomes impossible for a person to clearly see the relationships among the 12 indicators and group or cluster them. Impossible by a human, but possible through a machine. That is where machine model k-means clustering comes in. It is an unsupervised model where it computes basically the distance between the indicators and assigns groupings or clusters. Now, it will not say if it is a high risk or low risk cluster. It will only say it is a cluster. It was OAG, our unit, internal audit unit, who assigned the meanings to the cluster. Next slide, please. So this is the summary of the output of the model versus the traditional model. One would say that in the blue circle, there's 13 high priority countries identified, while in the model, the green one, we assessed 11 high priority countries. The overlap between the model and the auditor judgment summary is 9 countries, which we felt was quite significant. So at this point, we felt that the model could be relied on as a validation tool to supplement the traditional model. At this stage, we have not gone into the point of replacing the traditional model, but rather supplementing it. Next slide, please. So this slide summarizes some of the key benefits we gained from this experience. From doing it once or twice a year, we now have the option and capability to run it as frequently as needed. The use of ML and automation, machine learning, has also allowed us to expand the dataset to more external data and dynamic or real-time data. And finally, this gives us a little more confidence that the auditor judgment approach is supported by machine learning algorithms that we have. The model is far from perfect, and we are continuously updating it to make it more end-to-end, to have more relevant data, and maybe to explore more other suitable models. But it has been a great learning experience for us in internal audit to understand machine learning better and how it can support auditors. So I would like to thank you all, and I now return you to Hock-Chye. Thank you.
Thank you, Pierre. For the next presentation, let me turn on my video. We're going to show you how we use drones. As you know, ADB, we finance projects both to governments as well as to the private sector. And as part of our audit, as Pierre mentioned earlier, we pick a few countries that are considered high priority, and then we will go down to the field and actually validate whether the projects were actually existed, or whether the progress of the project were actually, as reported back by our project team to the managers in Manila. Manila being the headquarters of the Asian Development Bank. So as part of the audit, we wanted to try something different. And this is where Harry came in. Harry actually suggested maybe we can use drones to verify some of our projects, especially in areas that we cannot get into. And in fact, you'll see when I play the video that you'll recognize many of the places because it's actually in your country. On that note, let me run the video. It runs for about 3 minutes, and hopefully you can also hear the sound. That basically concludes how we use drones. I'm certain you would have a number of questions on how we use drones, and do we have to get a license to do it, or how do we actually go about doing it? Harry will stay behind to answer any questions they may have on drones. And for using this drone technology, we are quite hopeful that in future, when we're able to visit countries, we are going to use more drones to help us verify the implementation of many of our infrastructure projects in Asia Pacific. On that note, let me hand over the next presentation to sorry. Okay, sorry about that. Let me the next presentation to Andrew, who will talk about how we actually use technology to verify our treasury transactions. Over to you, Andrew.
Thanks, Hock-Chye. Good afternoon from Manila. I'm Andrew Wang, and I'm pleased to share our journey of continuous monitoring tool on treasury transactions in this session. Video during the presentation. Okay, first, we will look at the high-level process flow for the tool. It covers data, processing, and reporting. As we can see in this slide, ADB treasury transaction data is not hosted in one single system. Therefore, we need to coordinate with various data owners for the optimal approach agreeable to both parties. While some data can be directly accessed from the database, some data needs to be provided by the data owners. In the latter approach, we need to further determine the data specification, data format, the time when data needs to be available, and the location where the data will be accessible. And then we use ACL to read these different format data from different sources, process the data, apply our rule-based tests. We also leverage on the data and the test result we gathered and use Python to experiment on the machine learning algorithm. Lastly, for the reporting, we use Outlook for email and Power BI for dashboard. The email is crafted so line users can easily see the test result and take necessary corrective actions. The dashboard, on the other hand, aims to provide information for the managers. The tool automates the whole process from data gathering to reporting and is scheduled to run daily at 10:30 p.m. as the agreed timeline for data is set at 10 p.m. Next slide, please. Okay, as presented in the previous slide, we have two types of tests, rule-based and machine learning-based. This monitoring tool contains mostly rule-based tests, as we originally designed the tool to automate the most frequent audit tests on the targeted risk area. The slide shows high-level data flow, which is identical to the previous slide, with the exception that in this slide, it highlights the major categories of a rule-based test in the tool, such as mismatch of trade detail, timeliness of the transaction processing, segregation of duty tests, and trade anomalies. Next slide, please. Okay, for machine learning, in 2019, we decided to test out machine learning algorithm in this tool. We consider this tool as a perfect candidate because we accumulated several years of source data and test results. This enables us to label the data, which is a requirement for supervised learning algorithm. One of the tests we perform is using the trade log to test if trades are verified. We feel this test is ideal for our experiment because trade verification process follows specific rules or pattern which long short-term memory algorithm or In short, LSTM is ideal for. As shown in the slide, LSTM is mostly used to recognize and learn a pattern from the training data sets and apply that pattern in the analysis of testing data sets. We use audit trail of over 300,000 transactions to train. The test result was provided together with the rule-based tests for comparison purpose. So far, the result has been satisfactory. In the lower part of this slide, you can see the difference of the two approaches. For the rule-based approach on the left-hand side, which you can see we maintain a lot of if conditions in the ACL script. While with machine learning, the process is totally different. What we do is we encode the data into numerical sequence, and we feed those numerical sequence into LSTM model. The algorithm is going to detect the pattern itself, and based on the result, we take a look and see whether the correct ratio is satisfactory or not, and then we apply the model to testing data. Next slide, please. So now over to the reporting. We have two ways of reporting, email and dashboard. This slide shows the email report automatically generated by the tool. It contains detailed information for tests with exceptions so that users can investigate to see if corrective actions need to be taken. In this example, on the right-hand side, all tests other than the test encoded begin with M07 and I06 pass without exception. So you will see a lot of zeros with the two tests as 21 showing there. Therefore, only two Excel sheets are attached in this email report. And I like to highlight that M07 and I07, if you can see the description of the test, these two are identical tests, except M07 is based on rules, while I06 is a machine learning model. And the identical result provide us confidence in the machine learning model as there is no change in business rules to date. In the following slide, I will start showing the dashboard reports. Next slide, please. So in OAG, we also try to promote data visualization to enhance the communication of data. And in this continuous monitoring, so the first data we show here is the daily trade profile. Besides some static data profile, which we see typically in treasury setting, we also presented some dynamic information such as daily average verification time on the upper right-hand side versus historical average and the value trade to be settled in the next 7 days. So it includes some of the moving data. And the next slide, please. Here we shows the historical trade profile, which the users can adjust the historical period and then to see the trend of the process and the trade profile. For the components in the dashboard, we actually collaborate with clients. So users are the one who has a major opinion to see what is the dashboard components they want to see. And then we develop the tool, so hopefully we can provide relevant business intelligence to the users. Okay, next slide, please. So besides trade profile, we also include the exception history generated by this tool in the dashboard. In this slide, it illustrates the historical trend of the exception for investment transactions. So the tool actually, we run for 3 types of transaction: investment, borrowing, and payment. So for each one, we will show we actually have the transaction history in the dashboard. So next slide, please. So finally, I'd like to share some key benefits of continuous monitoring tool for us. It allows us to cover all transactions and provide more timely information to the client, which also enhance governance of the process by empowering first line of defense. Thank you. Now I will hand over to Marisol for the next topic.
Thank you, Andrew. Good afternoon, ladies and gentlemen. I am Marisol Del Rosario. I'm from the Operations Audit Team of OAG of ADB. We'll also be putting off my video for bandwidth consideration. For the next audit application, let me first give a background of the ADB lending operations. ADB basically lends to sovereign and non-sovereign entities. Sovereign lending would mean lending to governments or state-owned enterprises guaranteed by the government, while non-sovereign lending refers to lending to private entities without government guarantee. In other words, this is with credit risk. All ADB projects are approved by the ADB board. These loans are given to ADB member countries of different types of lending modality and to different sectors such as finance, energy, transportation, agribusiness, or health. After board approval, loan agreements containing the terms and conditions are signed by ADB and the counterparties. For our non-sovereign project audits, the loan agreement is a major basis of our audit tests. Next slide, please. The main challenges for internal audit on non-sovereign projects are the volume and complexity of agreements auditors have to review and analyze, combined with the lack of established system of monitoring covenants contained in the loan agreements. The current audit approach is for auditors to read and analyze agreements to identify and understand key clauses, which may take at least 3 hours per agreement, with agreement pages ranging from 50 to 100, with no assurance of completeness. After which, auditors may retype or copy and paste to an Excel database to organize and compile the clauses. This has become very challenging and time-consuming. Next slide, please. We thought of solving this challenge by partnering with Deloitte, our external auditor, to experiment on using a contract analysis software known as Argus. In Argus, the process is basically to import the agreements into the application, process the document into a machine-readable form. Argus then searches and reviews the agreements using machine learning tools. It then analyzes extracted data and export the report to Excel or other application for reporting or further analysis. Next slide, please. This is a sample input loan agreement in PDF form, which Argus automatically converts into a machine-readable form, and then uses machine learning to identify the concepts and clauses the auditor specifies. Next slide, please. This is a sample output where extracted clauses are exported in an Excel format file. It also has an analysis chart where a summary of the clauses is presented for comparison and analysis across multiple agreements. But we would like to stress that this undertaking with Deloitte is basically experimental. So far, we have processed 60 of around 140 agreements, and training of the machine and refining the results were temporarily suspended subject to further assessment. We are still open to exploring other similar applications given the limitations that we have seen so far in the application's current ability to extract accurately, rated at only around 30%. This would mean 70% of the extracted clauses have to be subjected again to manual review and retraining. Next slide, please. But in terms of uses, we see potential use of the application in reviewing compliance with relevant agreement requirements and in analyzing and comparing key clauses across countries, sectors, or project risk ratings. We also see value in the data warehousing of the loan agreements for further analysis. Next slide, please. Finally, on the benefits, by using the application, we see potential benefits in enabling us to do population testing of completeness of key clauses, while at the same time, if we still do sample testing, the application enhances sample effectiveness, meaning our sampling methodology would have clearer and more credible basis. Likewise, the application can increase our efficiency in reviewing multiple and complex agreements. Thank you, and I pass on to Christ Ian for the next presentation.
Thank you, Sol. Good afternoon, everyone. I am Christ Ian from the Data Analytics team of the Office of the Auditor General. I will discuss about how we make use of bots to automate some of our audit processes, such as validation of loan covenants. Please allow me to turn off my video in a while until the end of this presentation. So just a brief background about this tool. So auditors used to manually download sovereign loan agreements from the ADB website, read each agreement to find loan covenant clauses, and check if these clauses were recorded in our system. So this whole process could take hours to complete for every loan agreement. So now with the use of this covenants validation tool that we developed this year, so all those manual steps mentioned are already automated. So this covenants validation tool automatically downloads loan agreements in PDF from the ADB website, converts these PDF agreements to text, and extract the loan covenant clauses, and check if these clauses are recorded in our system. Next slide, please. So this is a sample output of the tool, which is in Excel file. So on the left side, you will see the summary sheet, which contains all events processed by the tool. And on the right side contains the covenant level results, showing which covenant clauses in an agreement were recorded or not in our system. Next slide, please. Right. So this is the overall flow of the tool, from downloading loan agreements, converting PDF agreements to text, and extracting covenant clauses, and also matching of extracted covenant clauses against what's recorded in our system. So the steps in orange were added to make the tool much faster and more efficient, which is making use of a covenants master file. So this file contains all the loans previously processed by the tool. So before the tool downloads the loan agreements, it will check first in the covenants master file if a loan number has been processed previously to avoid duplication, and thus saving more time. Next slide, please. All right. So this is the Power BI dashboard that we've also created to help us visualize and interpret the results of the tool better. This contains the covenants profile of all ADB developing member countries. So we will see more of this during the demo video of the tool at the end of this presentation. Next slide, please. So this is the summary of the key benefits in using the tool, which are first, it allows auditors to perform population testing instead of just a sample. Second, instead of manually reading each agreement that could take hours to complete, we now have a bot that could do the manual task for us. And last but not least, with hours saved in doing manual work, auditors can already focus more on analytical tasks, such as reviewing exceptions. All right, so now we proceed with the demo video of the tool. And should you have any questions, clarifications, we are happy to answer them later during the Q&A. Thank you very much.
Before we can run the tool, we need to prepare the input template containing the loan details. So this is a sample input template with 6 required columns such as the loan numbers, project numbers, modality type, country, sector, and effectivity date. Once done, we can proceed to run the tool. Just double-click the orange icon and a black window will appear. Just let it run for a few minutes, depending on the number of loans to be processed. Average processing time ranges from 5 to 15 minutes. As you can see, the tool downloads the loan agreement in PDF format from ADB website and saves it to the folder where you ran the tool. After which, it will automatically open your Google Chrome web browser to download the project documents from ADB's internal system. The tool uses Selenium WebDriver, which simulates actions done by user when manually downloading project documents such as typing project numbers, clicking tabs, buttons, drop-down menus, etc. Once document is found, the tool saves it in Excel format. Now the download part is done. The tool will now convert the loan agreement in PDF to text file. Once converted, it will extract the covenant clauses and check each one against the Excel file which the tool has downloaded from the system for existence and completeness. The tool will then generate an Excel file which I have shown earlier in the previous slides. First sheet is the summary sheet containing the loan numbers processed by the tool, as well as how many covenant clauses out of the total were recorded in the system. Next sheet is the sample loan level results, which shows the breakdown of covenant clauses that were recorded or not in the system. Last sheet is the detailed information sheet, which contains other loan-specific details and is also the data source of our Power BI dashboard. So here is the Power BI dashboard that shows covenant clauses profile of ADB's developing member countries. You can filter a specific country of interest and be able to see the covenants profile. You can also drill down on each chart by clicking on a portion, then drill through. This drill through page shows the loan details such as the website link to the loan agreement, the existence ratio of covenant clauses, as well as the file link to the individual loan level results.
That concludes the presentation report. And Now we are proceeding to